Right now, at this exact moment, something is happening 270 million kilometers above your head. An object the size of a small mountain is slowing down, and it shouldn't be able to do that. 3 hours ago, NASA's Deep Space Network picked up something that made the entire control room go silent. The interstellar visitor we've been calling 3I/Atlas, the one that entered our solar system 6 months ago, just fired its engines. Except it's supposed to be a comet. Comets don't have engines. I'm going to show you the data that's being passed around encrypted channels right now. Data that suggests we are not looking at a rock from another star system. We're looking at something that's watching us back. But I need to walk you through this carefully, because what I'm about to reveal at the end of this video, it changes everything we thought we knew about our place in the universe. Real quick, where are you watching this from right now? Drop your location in the comments. I want to see how global this audience is, because what's happening above us right now, it's happening above all of us, every single person on this planet. If you're not subscribed, do it now. The next 48 hours are going to be critical, and I'll be updating this channel with every piece of information as it comes in. Hit that bell. You need to see what happens next. Okay, let me take you back to where this story really begins, because to understand what's happening right now, we need to understand what should have happened and didn't. 6 months ago, astronomers detected an object entering our solar system from interstellar space, the third one ever confirmed. They called it 3I/Atlas. At first, it seemed normal. Well, as normal as a visitor from another star system can be. It came screaming in from the direction of the Crab Nebula at 31 kilometers per second, fast, but not too fast. It had the spectral signature of ice and rock. It had a faint coma, that fuzzy cloud that forms around comets when they heat up. NASA called it a dirty snowball. The European Space Agency agreed. Case closed. Except it wasn't. In August, something strange happened near Mars. 3I/Atlas passed within 50 million kilometers of the red planet, close enough that we had eyes on it. Multiple telescopes, orbital assets. We should have gotten our best look yet. Instead, the object went dark. Not gradually, not naturally. It dimmed by 60% in less than 12 hours. NASA's explanation? Outgassing event. The ice was sublimating unevenly, changing the reflectivity. Textbook comet behavior. But then, the MAVEN orbiter, NASA's Mars atmosphere probe, went offline for 6 hours during the closest approach. Total communications blackout. When it came back online, NASA said it was a scheduled maintenance window. Scheduled maintenance during the most significant interstellar flyby in human history. The amateur astronomy community didn't buy it, and they started watching more carefully. In October, a research team in South Africa published something that should have made international headlines. They'd been tracking 3I/Atlas with a radio telescope array, looking for any electromagnetic signatures. What they found was a periodic radio emission at 1.42 gigahertz. That's the hydrogen line, the universal frequency, the one SETI has been listening to for decades, because any sufficiently advanced civilization would know we're listening there. The signal lasted for 8 days, then stopped. The paper was peer-reviewed, it was legitimate, and then it disappeared from the preprint server. Just gone. Scrubbed. I managed to get a copy before it vanished. I'll link to it in the description, but I don't know how long that link will stay active. By November, 3I/Atlas was on its way toward the inner solar system, heading for perihelion, its closest approach to the sun. This is when comets are supposed to put on a show. The heat vaporizes the ice, creating massive tails millions of kilometers long. They become bright, spectacular, impossible to miss. 3I/Atlas did the opposite. As it got closer to the sun, it got dimmer. The albedo, the amount of light it reflects, dropped to less than 4%. For context, charcoal reflects about 4% of light. Fresh comet ice? That should reflect 60%, maybe 70%. This thing was absorbing light like a solar panel. And that's when the wobble started.
Last week, a preprint paper appeared on the archive server.
It's titled Anomalous Acceleration and Structural Oscillation of Interstellar Object 3I-Atlas. The lead author is a physicist from Caltech who specializes in orbital mechanics. The paper describes something that shouldn't be possible. As 3I-Atlas rounded the Sun at perihelion, the point of maximum gravitational stress, it developed what they're calling an anti-tail. In comet science, that's usually an optical illusion. You see the tail pointing toward the Sun because of your viewing angle. It's a perspective trick. But this wasn't an illusion. The anti-tail of 3I-Atlas is a physical structure, and it's massive. Ground-based interferometry measured it at over 380,000 kilometers long. That's almost the distance from Earth to the Moon. But here's the part that broke the models. The tail is oscillating, back and forth, left and right, with a frequency of one complete cycle every 144 minutes. Regular, precise, mechanical. Comet tails don't do that. They can't. They're made of dust and gas pushed by the solar wind. They're passive. They drift. They disperse. They don't swing like a rigid pendulum. Dr. Avi Loeb, yes, that Avi Loeb, the Harvard astrophysicist who's been talking about interstellar visitors for years, he released a commentary 3 days ago, and his words are being passed around every encrypted research channel I have access to. He said, and I quote, "A periodic oscillation of this magnitude in a structure of this scale implies an active transfer of momentum. In the absence of observed outgassing jets capable of producing such force, we must consider the possibility of articulated structural elements under autonomous control." Autonomous control. He's saying it's moving itself. 2 days ago, spectroscopic analysis came back from the Atacama Observatory in Chile. They analyzed the composition of the anti-tail, and it's not water ice, it's not dust, it's not anything we've seen in a comet before. They're detecting ionized metals, rare earth elements, complex hydrocarbon chains that shouldn't survive in the vacuum of space. And the kicker, there's a magnetic field, strong enough to deflect the solar wind, strong enough to maintain the coherence of a structure nearly 400,000 kilometers long. You don't get that from a snowball. And then yesterday, an amateur astronomer network in Japan released photometric data that's been making the rounds on Reddit at X. They've been tracking the brightness of 3I-Atlas every single night for the past 2 months. The light curve, the graph of brightness over time, shows something impossible. The object is dimming in pulses. Every 144 minutes, like clockwork, the brightness drops by 0.4 magnitudes. Then it returns to baseline. Drop, baseline, drop, baseline. It's a pattern, a deliberate pattern. When you overlay the timing of these brightness pulses with the oscillation of the anti-tail, they match perfectly. When the tail swings to the left, the object dims. When it swings to the right, it brightens. This is not a tumbling rock. This is not random. This is a mechanism. And here's where it gets terrifying. Yesterday, the Minor Planet Center updated the orbital elements for 3I-Atlas. They do this routinely. It's just a refinement of the trajectory as more data comes in. But buried in the updated parameters is a line that most people won't understand. It says non-gravitational acceleration detected, magnitude 1.2 times 10 to the minus 8th AU per day squared. That's tiny, almost imperceptible, but it's there. The object changed its trajectory. It adjusted its course by a fraction of a degree right as it passed the sun. It's not following a ballistic path anymore. It's under power.
So here we are, right now, December 19th, 2025. 3I burst Atlas is at its closest approach to Earth, 270 million kilometers. In astronomical terms, that's right next door. Close enough that amateur telescopes can see it. Close enough that every major observatory on the planet is pointed at it. And 3 hours ago, the Deep Space Network detected something that NASA hasn't publicly acknowledged yet. A transmission. Not from 3I Burst Atlas, to 3I Burst Atlas. Someone or something sent a signal to it, and it responded. I told you at the beginning I'd explain what's happening right now. Here it is. The anti-tail, that massive, wobbling 380,000-kilometer structure, it's not pointing away from the sun like a comet should. It's pointing toward the galactic center, toward Sagittarius A star, toward the core of the Milky Way. The same direction it came from. It's not a tail, it's an antenna, a high-gain transmission array, and right now, at this very moment, it's beaming data back home. The wobble we detected, that's not instability, that's modulation. That's a signal being encoded into a carrier wave. The dimming pulses, that's data compression, binary packets being transmitted at light speed across 26,000 light-years of space. We are being scanned, cataloged, indexed, and the report is being sent right now. Here's the part that no one's talking about yet, the part that's going to hit the mainstream in the next 24 to 48 hours. If 3I Burst Atlas received a response 3 hours ago, a response that traveled here at light speed, that means whoever sent it was listening from a distance of about 3 light hours away. That's roughly the distance to the outer solar system, somewhere near Uranus or Neptune. There's something else out there, waiting, watching, and it just woke up. In the next 12 hours, 3I Burst Atlas will reach its maximum transmission efficiency. Then it will begin its exit from the inner solar system. By this time next week, it'll be too far to track with ground-based telescopes. But the question isn't where it's going. The question is, what happens when the message arrives? I'll be monitoring every channel I have access to, every data leak, every preprint paper, every encrypted message board, and I'll be posting updates here as they come in. Subscribe if you haven't already, turn on notifications, share this video with everyone you know, because the mainstream media isn't covering this. Not yet, but they will. The countdown has started, and we're all witnesses to first contact. Drop a comment right now. Tell me what you think. Tell me I'm crazy. Tell me I'm onto something. I want to hear from you. Because whatever happens next, we're in this together. I'll see you in the next update.